Hey class, Mr. Hanji here. For today's lesson, we are going to be taking a look at section 2.1, which is going to deal with translations. Now, this is our introduction into Module 2, and Module 2 is going to cover different types of transformations. So we're going to take a little more in-depth look at transformations, in particular translations, reflections, and rotations. Now, today's look is at translations, which is just a fancy way of saying sliding a shape from one spot to another. So today we're not going to rotate, we're not going to flip, we're not going to worry about any of that stuff. We're just going to slide a shape from one spot to another based off what they ask us to do. So let's get started and let's take a look at our learning goal for today. Today we only have one learning goal, which is you will be able to draw the translation of a shape in the coordinate plane along a vector. So we're going to go through and translate a shape along a vector. So what is a vector? Let's talk about that. So a vector is a quantity that has both direction and magnitude. The initial point of a vector is the starting point, and the terminal point of a vector is the ending point. The vector shown may be named vector EF or vector V. Now, we're not really going to be worried too much about the vector and the name and stuff, more about what the vector is telling us. So, what a vector does is it tells you from the direction that you need to move the shape and by how much. So, it's going to tell you distance, it's going to tell you amount, and then in which direction. So, that's going to be kind of our key points for how we go through and translate shapes. So we're going to talk about how to translate along a vector, but also through coordinate notation. So those are going to be the two things we look at today. All right. Now this part right here just kind of goes through and states what a translation is. So we'll go through and talk about it briefly, but like I said, really a translation is just sliding a shape from one spot to another. And in this case, we're talking about it along a vector. All right, so translations. It is convenient to describe translations using vectors. A translation is a transformation along a vector, such as a segment joining a point and its image has the same length as the vector and is parallel to the vector. So, they're going to provide you a vector in the coordinate plane. Okay, that's going to tell you the length and distance that you need to transform each point. Okay, if we were to go through with a ruler and measure how long this vector is, that is how long and how much this point has moved and in that direction. Okay, and the same is going to be for points A to A prime, B to B prime, and C to C prime. All of these arrows are going to be the same length, and they are all going to be in the same distance, and they are all parallel to each other, which means they move in the same direction. All right, so with that said, let's go ahead and get into some examples for us today. And we're going to take a look at two different parts here. And they're going to ask us to go through and draw the image of triangle ABC, or as we get to this one, the quadrilateral or parallelogram ABCD. So we're going to go through and draw the image of these two shapes for parts A and B after a translation along the vector. So the vector tells you distance and direction. All right, so if we look at A, so we have triangle ABC, and we need to move it along this vector here. So a couple ways we can go about this. You just have to go through and determine how much the vector moves right or left, and then up or down. Order doesn't matter in which way you start that. So let's go through and first identify our vector. So the vector is going to go in this direction by that amount. So what is the amount? Well, we move to the right, 1, 2, 3, 4, and then we move up 1, 2. So we go to the right 4, and then up 2. So what that means with that vector of being to the right 4 up 2, that means we move every single point on that triangle to the right 4 and up 2. Now, thankfully, to be able to do this, all we have to do is take the vertices of the triangle and move those to the right 4 up 2. So if we start with A, we go to the right 1, 2, 3, 4, and then up 2, so 1, 2. So that is going to be the point of A prime. Now B prime is 1, 2, 3, 4, and then up 1, 2. And that's the point of B prime. And then for C, it's going to be to the right 4, 1, 2, 3, 4, and then up 2, 1, 2. And that is the value of C prime. Now, unlike when we talked about this in section 1.3, okay, for these ones we're not worried about the actual coordinate point. We're just drawing it after a translation along the vector. So at this point, all you would need to do is just go through and connect your points for your shape. And your triangle looks like that. So each point of this triangle was moved to the right 4 and then up 2. And much like we've talked about back in section 1 and 3, this is a rigid transformation because the triangles keep the same shape and size. Okay, same shape between the two triangles, and they are the same size. So that is going to be how you go through and translate a shape along a vector. And that's all we had to do for part A on that one. All right, let's take a look at B. So for part B, we have the parallelogram ABCD, and then we are given this vector V that moves from here to here in this direction and by that amount. So we need to go through and identify how much it has moved, so that way we can go through and draw it. All right. So, again, doesn't matter which way you go through and start. Okay, last time I did right or left first and then up or down. This time let's go ahead and move up or down and then right or left. So I'm going to go up 1, 2, 3, 4, 5 spots. And then I'm going to go, let's write a 5 first. And then we're going to go to the left 1, 2, 3. So we went back 3 to the left 3. And because we went back, I'm going to signify that as a negative 3 for our purposes on this problem. Okay? Anytime that you move back or down, okay, consider that as a negative direction to the right or up. That is considered a positive direction. All right, so now at this point, all you have to do is go through and move all of your points back or up 5 and then back 3. So if we go through and do that, we have, let's start with A. So up 1, 2, 3, 4, 5, and then back 1, 2, 3. So that's point A prime. Then B is up 1, 2, 3, 4, 5 to the back 1, 2, 3. And then we're going to go through and do that for the others. So all right, so I now have all of my points plotted for the prime and the transformed points. So then all I have to do is connect the points, draw my image, and then we will have transformed our shape for this problem. And that is the transformation for part B. So again, because we have just done a translation along the vector, This is a rigid motion because we've kept the same shape and size. All we've done is translate a shape, and that is considered a rigid motion. All right, so that is example one. That is really going to be about half of the stuff you're going to be asked to do today, or half of the content really for today. We'll kind of get into practicing a few others, and that's what we'll look at moving forward. So, before we do, we have one point that I do want to highlight and talk about before we jump to example 2 and 3. So, a vector can also be named using component form. So instead of necessarily parentheses, okay, these look a little different. They almost look like the end of arrows. Kind of just a vector form of parenthesis. A comma B, which specifies the horizontal change A and the vertical change B. From the initial point to the terminal point, the component form for the vector PQ is 5 comma 3, meaning we went to the right 5 and then up 3. So when you are thinking about going through and writing a vector in component form, okay, know that it is going to be this idea. So it's going to be right or left, comma, up or down. Okay, and the number just comes from how much you move it right or left, and then up or down. And again, when you're thinking about this, I think I have enough room here. Okay, your number is going to be positive when you move right or up, and then it's going to be negative when you move left or down. And I do have enough room. All right, so that's kind of a really helpful key and information to know. So the first number is moving it right or left. The second number is moving it up or down. Just kind of think of it like as your coordinate point x comma y, where you go right or left and then up or down. And again, positive direction is considered right or up. A negative direction is considered left or down. And that's really what this whole point here is going to be talking about. So I'm not going to necessarily get into that. All right, so with that said, we're going to jump on into example 2 on the second page. And what we're going to start out with is actually the rules for translations along a coordinate plane using coordinate notation. So we've talked about coordinate notation before in section 1.3. All it does is just tells you how much you're moving it right or left, up or down. So if we're moving something to the right, we're going to be adding a number to x. If we're moving something to the left, we're subtracting it from x. And then for translation up, we're going to be adding a number to y. To move a figure down, we're going to be subtracting from y. So again, this kind of goes back to the idea that I talked about on the front side, where it's up, nope, it's right or left, comma, up or down. And kind of ran out of room there. All right, so right or left and then up or down based off of our stuff. So x is right or left, y is up or down. Okay? So when you see that, you'll see kind of x comma y goes to x plus or minus a, comma y plus or minus b. And that's going to tell you which way that you need to move it. All right, so example 2 is going to ask us to calculate the coordinates of the image when we are given the vector. So we're provided the vector, we have to go through and state what all the points will be. You will see this pop up on homework and potentially on a quiz. So it is a handy thing to use without needing a graph to do this. So for part A, it says the pre-image coordinates are -1 or -2, comma 1, -3, comma -2, and -1, comma -2. And our vector is 4, comma 6. What this vector means right here is we are going to move each of the points as x plus 4, comma y plus 6. And that's going to be the vector that we use, or the coordinate notation, for our problem here today. So what this means is that I need to add 4 to each of the x values, and that I need to add 6 to each of the y values. So with that said, let's go ahead and get started on doing that here today. So if we go through and transform this first point, so I have -1, comma, I did it again, -2, comma 1. So if we go through for each of the points and apply the transformation, okay, so if we start with -2, if I do -2 plus 4, okay, we end up with 2. So the x value of our first point is 2. And then for the y value, I have 1, and it's plus 6. 1 plus 6 is going to be 7. So you're going to go through and transform the rest of the points for this. And if we do that, -3 plus 4 is going to be 1. And then if we do -2 plus 6, we're going to end up with 4. And then the last point, we go through and add 4 and then add 6. We're going to end up with 3, comma 4 for our last points. So that is changing the points -2, 1, -3, -2, -1, -2, along the vector 4, 6, which gives us 2, 7, 1, 4, 3, 4. All right, so that is how you go through and change points along a vector, just knowing the points. Now, we're going to go through and do that for part B. I'm not going to run through every component of part B just to save time, but I am going to help you set up your vector of -2, comma 3. And what that vector implies is x, comma y becomes x minus 2, comma y plus 3. Okay, it's -2 because this is a -2, and it's plus 3 because it's a positive 3. So you're going to use your coordinate notation for our vector, and you're going to go through and plug all these points into this coordinate rule to get your points for the image. All right, so with that said, let's continue on. Now, example 2 continues with actually going through and drawing them. So if we look at C, it asks us to draw the pre-image and image of each triangle under a translation along -4, comma 1. So what this vector here means is that we are going to move each of the points to the left 4 and then up 1. If it helps to see it in coordinate notation form, it's x minus 4, comma y plus 1. Now, if you're doing these on paper, there's a couple ways you can do this. You can go through and plot your points first for the pre-image. So if I do that, A is going to be at 2, comma 4. B is at 1, comma 2. And C is going to be at 4, comma 2. So then I have my points of my triangle, and I can go through and form my triangle ABC. So that is my pre-image. Now we have to go through and figure out the image, which means we need to go through and transform each of the points. Now, like I said, there's a couple ways you can do this. We can know the fact that my vector is telling me -4, 1. So that means I would move each point back 4, up 1. And then you can just go through and draw each point. To kind of continue the spirit of example 2, I want to go through and find the coordinate points for A prime, B prime, and C prime. And the way that we're going to do that is we're going to apply our vector to each of the coordinate points, and we can do that using coordinate notation. So it's x minus 4, comma y plus 1. So that means we're going to subtract 4 from all the x values. So if we do 2 minus 4, we get negative 2. If we do 1 minus 4, we get negative 3. And then if we do 4 minus 4, we're going to end up with 0. Then next, we're going to go through and apply the y plus 1 to each of the y values. So all we're going to do is just add 1 to all of these numbers. So we're going to get 5, 3, and 3. So those are our new coordinate points. So if we go through and plot these for A prime, B prime, and then C prime, we end up with our new triangle being right there. So we have drawn triangle ABC, our pre-image, and then we've gone through and transformed triangle A prime, B prime, C prime, and that is going to be our image. So that is our answer for that problem right there, and that's how you're going to do either C or D. If you ever want to double check your work, you could then go through and just check each point. So it's negative 4 and 1, so I'd go back 1, 2, 3, 4, and then up 1, and that does check out, so my math is correct, and what I did to transform that shape is correct as well. So that is going to be how you do parts C and D. I will leave part D for you if you want some extra practice. You can always take a look at my completed notes if you want to see how I did that one, and if you are on the right track. All right, so with that said, we just have one example left to go, and that is what we're going to take a look at now. So example 3 is going to ask us to specify the component form of the vector that maps triangle ABC to triangle A prime, B prime, C prime. So what we're going to do is we need to figure out what our vector is that took us from this triangle to this triangle. Now, for this problem, they have provided me my vector, so that does help. And my vector is drawn from point B to B prime. We just have to figure out how much and then in which directions. So we're going to go through and do the same thing we did with example 1, where we're going to go through and figure out the vector. So it doesn't matter if you go up or down, left or right first. I'm going to go down first, so we go down 1, 2, 3, 4, and then we're going to go to the right 1, 2, 3, 4, 5. So I went down 4, so because I went down 4, that's a negative direction, so that's a negative 4. And then we went to the right 5, going to the right is positive. So then we end up with a negative 4 and 5. Now, again, and I've written this a couple times, but just as a reminder, the first number we are moving right or left, and the second number is going to be up or down. Okay, so right or left, comma, up or down. So using that idea, we move to the right 5. So that's going to be a 5 first, and then we went down 4, and that's our negative 4 for the second number. So my component form of the vector is negative or 5 comma negative 4. If I wanted to write the coordinate notation for this, it would be x plus 5 comma y minus 4. So that's just a little add-on bonus to change it from component to coordinate notation. Alright, so that is going to be how you do parts A and B. I'm not going to run through the full thing of part B, but I do really want to highlight something, because if we look at B, there's no vector drawn, okay? So they don't have a vector like they drew for us from B to B prime. Understand this, to be able to figure out your vector, you just need to choose one set of points. So you can choose A, B, or C. And all you're going to do is figure out how you get from that point to its prime. So let's say, for example, I want to go from point C. I had to figure out how much I moved right or left, up or down, to get to its prime, so C prime. You don't have to do this for every point, you just need to choose one. So all you would do is kind of chart a path, how you'd get from there going horizontally and then vertically, or vertically then horizontally. So that would be my path for this one, is that I went to the right and then up. So for this one, for C to C prime, I went to the right 1, 2, 3, 4, 5. And then I went up 1, 2, 3. Because I went to the right, that's positive. Because I went up, that's positive. Okay, you're going to start at the pre-image point, and you're going to work your way to the prime or the image point. So I will leave for you to go through and write it in vector form per part B, and also go through and put it in coordinate notation. As always, you can take a look at my completed notes. Alright, so that is all that I have for you guys today on section 2.1 on translations. So if you have any questions, just ask me the next time you see me. Otherwise, that is it for today. Thank you for listening, and I hope you have a great day. Bye.